Phone cameras keep getting better, bigger sensors, more megapixels, and computational photography. But there's one thing that innovation hasn't solved: accurately capturing the full range of human skin tones. For decades, the entire imaging pipeline was calibrated around one baseline. Everyone else? Left in the shadows. TECNO has built universal tone to fix that. New databases, new algorithms, a rebuilt system. Today, we're looking at how they did it and what's at stake when cameras get it wrong.
Accurate skin tones in photography matter not just because it's not a visual question, it's a social question. How we look and how we represent ourselves. The reason why I dress like this, I want the world to receive me in a certain way, and if images aren't accurate, then I'm not being represented accurately.
Can you share a time when you realized the camera wasn't showing an accurate image?
I think even going back to when I was a child, thinking about school photos or family photos, I come from a mixed background and I had a lot of friends from all sorts of different cultures. And I realized that cameras weren't being entirely honest when friends who had skin tones like me were always a bit blacked out and shadowy, and everyone else looked great. And I was like, well, that's not how we look. And it's actually embarrassing. As a child, I still feel some of that embarrassment from images not quite telling the truth when I was a kid. When cameras consistently get skin tones wrong, I think you're at risk of affecting the historical record. We're not just talking about family photos, we're talking about accurate representations of cultures that have been visited over time. We're talking about things that are happening now, daily moments. And I think in an AI age when everything is up for grabs, the truth is up for grabs, what we see is up for question. If we can't even trust real images captured with actual cameras, then where do we go from there? There's no truth in anything that we see.
Finding that truth means moving beyond simple filters. It requires a bridge between the cold physics of light and the warmth of human perception, a foundation built on rigorous color science.
If there's no color science involvement, the color accuracy on our imaging system would be very bad. If there's absolute color accuracy, that means there's no difference between the physical world and the digital world. At the moment, the problem is in the early imaging system, and all the color system is calibrated only using lighter skin tone. The real world consequence is if we don't have the data, and then the darkened skin tone is misrepresented in the photograph, in the video, and even for the medical imaging. It's more inclusive if we can be able to develop technology. Actually, it's for all different ethnic groups.
Solving that problem of misrepresentation requires more than just a goal. It requires years of presence in the field. To find a solution, the work had to start at the source.
I worked for TECNO 15 years, and I went to African markets in 12 years ago. And I wanted to find the bad experience of our users. Universal tone solves the long-standing problem of inaccurate skin tone representation in smartphone cameras, especially for non-white skin tones. Actually, our algorithms are trained by our own data. We have the biggest data set of the skin tone around the world, not from the internet. So that's why we can make sure this skin tone performance technology can really run well on our customers, especially for the new emerging market.
To solve the legacy of bias in camera technology, Professor Xiao and TECNO have moved research out of the lab and into the field. At the heart of this work is a tool unlike any other: a multi-tone color card with 372 scientifically calibrated skin tone patches. It requires thousands of data points to create, measuring the unique reflectance of skin on the face and body to account for natural physiological variations. But the science also accounts for the environment. The system uses a local tuning engine to adjust for regional lighting. It can balance the intense high UV light in Saudi Arabia during the day, or the specific way the humidity in Indonesia changes how light bounces off the skin. This technical data is then layered with physiological testing to understand the perceptual truth of a healthy skin tone in different regions. This bridge between raw data and human perception is the core of Professor Xiao's perceptual fairness framework. The result is a 50% leap in accuracy, ensuring the first time the camera sees you exactly as you are.
We actually developed standard method to collecting skin color data, and this sort of method can be used for any the ethnic group in the future. TECNO has a lot of experience in the facial color reproduction for darker skin, right? And by work together to collecting the new database, then we can testing and co-develop new algorithm to make the color reproduce better. And from the sociology point of view, and we consider about fairness, which is beyond both the profit and the research.
Turning academic research into a consumer product requires a new kind of testing environment. This led to the creation of a joint lab with DxOMark, where robotic systems and 3D models are used to benchmark the camera's accuracy against a truly global spectrum of skin tones.
With TECNO, we work together to build this laboratory to be fully automated. It's where you put your smartphones to simulate the human shaking. And this is very important to test in real conditions, like when a human holds a phone. And the other part is the setup side. So you have lightings, which are very complex lighting to simulate any kind of lightings from daylight to very low light. And you have the scene that is lighted, which is made of many different kind of charts. It can be realistic mannequins or mathematical charts to calculate some very complex metrics. And at the end, you get thousands of pictures that we put in a software that we have made to do automatic analysis and to build a report. If you take a manual laboratory, maybe it takes a month to do all these shots and then to do all the aggregation of the measurement into a report. And we have automated everything. So you click on a button and you get your report in a couple of days. And this is how we ensure that you have tested so much conditions that you cannot have any bias in your algorithm. Unfortunately, in the laboratory, there are a lot of turnovers in general. We see the quality of the shoots and the measurement decrease over time. And with an automated lab, you don't have this problem.
While robots provide consistency, the camera still needs a subject. This led to the lab's most unique feature, a series of hyper-realistic models.
To build these models, we had to go to a very high-end special effect makers to be able to build something realistic enough that when you see it, you cannot imagine it's not a real human. Instead, that it's not moving. And because also, the silicone that is used in these special effects, it's really close to the human skin.
These lab results provide the raw data, but the real work happens inside the device. This is where the universal tone system takes over, using a series of computational engines to translate those lab benchmarks into a final image.
It's really a complex technology, except you need to know the exact requirement from the customers. You must have the corresponding technologies to make sure that this technology can really work well in the local market. So universal tone technology actually includes three engines, like the skin tone restoration parts and algorithms to make the skin tone can be corrected exactly to each country. And also we have localized tuning technology to make sure we can customize for each region of the country in the world. And also we do a lot of local market research, and maybe month by month, year by year, continues to accurate the requirements, maybe the change. So we need to follow the customer's trend.
Accurate skin tone representation isn't just about looking good in photos, it's about the data that trains facial recognition systems, biometric authentication, and AI algorithms. If the camera gets skin tone wrong at capture, that bias flows downstream into every system that uses those images.
Bias often comes from data. If your training photos don't include many skin tones, the AI won't treat everyone fairly. It's not just about looking good. With more inclusive data and the scientific testing, cameras can be more fair and more accurate for more people.
Facial recognition and AI is becoming so prominent, and it's I mean, in some cultures, it's ubiquitous, it's everywhere. And if you don't have AI trained on, and cameras trained on accurately representing darker faces, we won't be seen, so our ID won't work. Or worse still, we'd be much more easily confused with other people who have just similar skin tones but completely different faces.
It's a concern shared at the highest levels of the biometric industry. Andrew Budd, CEO of iProof, a company providing facial verification for governments worldwide, sees the stakes clearly.
Biometrics have the potential to really transform people's experience in online and offline life and to create trust. But in order to succeed, it relies upon acceptance by everybody. And so everyone has to have confidence that it'll work for them. And therefore it's vital that any system works for any kind of face type, regardless of skin tone or age or gender.
So that's the technical reality. Bias at capture becomes bias at scale. But let's bring this back to the person holding the phone. What actually changes when the technology finally works?
When people see themselves authentically represented in photos, it restores confidence and self-recognition. In Africa, our work focuses on addressing dark skin image inaccuracies, while in Southeast Asia, the Middle East, and Latin America, localized databases and algorithm optimization ensure adaptation to regional light, environments, and aesthetic preferences. Ultimately, universal tone goes beyond color accuracy. It embodies cultural belonging and visibility.
Something that I'm seeing really interesting is the smartphone and camera world are super competitive. But what you're seeing is some smart brands are seeing that there's a customer base there that's not being spoken to. Brands like TECNO Mobile have a huge following in Africa. And as a result of that, they started creating camera technology that actually measures skin tones based on shade as well as richness. And the images that they produce with people of color are way more impressive than anything I've seen targeted at that market previously. What you will see is that if brands realize that people of color are paying customers, which we are, and they start to create products that accurately represent us, they will see an industry shift. People will start to choose those products and services that reflect them.
For most of photography's history, capturing diverse skin tones accurately was never the priority. Sensors and algorithms were built around a narrow standard. Universal tone is TECNO's answer, rebuilt from the ground up with inclusive databases and adaptive algorithms. Now the question is whether this becomes the industry standard, because what's at stake isn't just better photos, it's the historical record and the training data shaping AI systems.